everyone, Katrina here, and today I'm going to show you a quick and easy way how to factor cubic polynomials using the Rational Root Theorem. Let's dive in and start with an example. Plus 5x squared minus 2x minus 24. In the previous videos, we learned how to factor quadratic equations. However, this one is cubic, so we have to use a few different rules. The generic form for a cubic equation is as follows. A times x cubed plus b times x squared plus c times x plus d. The first step that we have to do is we need to determine all the possible roots for this polynomial. We can find all the possible roots by looking at d over a. All the possible combinations, and remember to consider both the positive and the negative values. So let's do that for our example over here. So already we can see that a equals to 1, so there's only one possible factor here. So let's now look at all the possible factors for d. So let's say factors of d. So we've got plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Lots of factors to choose from here. So we know it is a possible root if our f of c, where c is our factor, equals to 0. So we have to go through our factors of d and see if any of them will render our equation up here equal to 0. The best trick is usually to start with the lower numbers as they're easier computationally to plug in, and most of the time they do work. So let's get started with that. So let's start with 1. That's going to be our test at the beginning. So let's do 1 cubed plus 5 times 1 squared minus 2 times 1 minus 24. So here we've got 1 plus 5 minus 2 minus 24. And we can see that this does not equal to 0. If I were to make the 1 negative, I don't think it's going to make much of a difference here. Let's move on to 2. Let's try out 2. So here we're going to have 2 cubed plus 5 times 2 squared minus 2 times 2 minus 24. Let's see what that gives us. That's 8 plus 5 times 4, which is 20, minus 4 minus 24. So this here makes 28, this here makes negative 28, so that means that this equals to 0. Hooray! We've already found a possible root for this cubic polynomial. So what that tells us, that tells us that f of 2 equals to 0. Therefore, x minus 2 is a factor of our cubic polynomial. So now that we know that this is a factor, let's dive into synthetic division in order to factor the rest of our polynomial. So in my previous video, we go over a synthetic division example. However, we'll continue with another example here as well. So the first thing we want to do is take our c value and line it up in the upper left corner. Then we have to grab all of our coefficients from our original problem. So here we're going to have 1, 5, negative 2, and negative 24. So let's write that down. So we've got 1, 5, negative 2, and negative 24. Let's go through the process of synthetic division. So we bring down our first number, which is 1. We then multiply this number by our c value. We get 2. And then we have to add all the numbers in our column. So we have 5 plus 2, which is 7. We're going to repeat this process. 7 times 2 is 14. Negative 2 plus 14 gives us 12. And then we do 12 multiplied by 2, which gives us 24. And then negative 24 plus 24 is 0. And this is exactly what we wanted to see. That means that the remainder equals to 0. And that confirms with us that x minus 2 is a factor. So that's a little good check. So again, if your remainder equals to 0, that confirms by remainder theorem and factor theorem that x minus 2 is a factor. Now what we have to do is we need to collect our remaining coefficients and factor this new quadratic equation. So we have x squared plus 7x plus 12. Now we want to use the skills that we learned from the previous videos to factor this quadratic equation. The first thing we notice is that our leading coefficient equals to 1. That means that we can use the quick and easy version of the product sum rule, if it allows. So our product equals to 12, this number, and our sum equals to 7. So let's look at all the possible factors here. So for 12, we have 1 and 12, and we have 2 and 6, and 3 and 4. We also have all the negative combinations of those. However, I can right away see that 3 and 4 multiply to 12 and add to 7. So we don't have to go any further in trying to solve this. So now I can set up my factored form, x minus x1 multiplied by x minus x2. And here I have the positive value 3 and 4, so I can plug that right in. So I've got x plus 3 and x plus 4. We're not quite done yet. We've done all the hard work, but we absolutely have to remember what was our first factor. X minus 2 is also a factor, so make sure to factor that in to our final answer. So let's add that right over here, x minus 2. And there you have it. We took this seemingly difficult looking cubic polynomial and we factored it with ease using synthetic division and also using our previously learned techniques about quadratic factoring. If you found this video helpful and interesting, drop a like, and please don't be afraid to comment below with any other questions that you have. I'm here for you, and let's do math together. Subscribe for more fun and exciting math videos. Can't wait to see you next time.